Hello everyone, welcome to my channel Cyber Hashira. In today's video, I will talk about a widely used and a very popular utility called OpenSSL. I've also created a new playlist which I will be using to group all videos on OpenSSL together. This video obviously is going to be just an intro. I'll talk about what OpenSSL is, what it is used for, and finally, I will show you how to set up OpenSSL on Windows and Linux. So without further delay, let's get into it. I have been using OpenSSL for many years now. I mostly use it for generating key pairs and certificate. I also use it to perform various operations such as calculating hash or to encrypt a confidential file. Sometimes I even use OpenSSL API in my C++ projects. I'm sure you must have seen me using OpenSSL based CA in some of my previous videos. OpenSSL has an implementation for almost all types of cryptographic functions. You can use it to encrypt your document. You can use it to sign your document. You can use it to generate hash. You can also use it to set up TLS on your web server. So it does not matter if you are a developer or an administrator or a cybersecurity expert. I'm sure there will always be something useful for you in OpenSSL. OpenSSL is open source, which means you are free to download and use it. You are allowed to make changes in its source code and build something new out of it. You're allowed to distribute your own modified software as described in the open source license. You are also allowed to freely use it for commercial and non-commercial use. OpenSSL is available for all operating systems. I don't think I have ever heard of an OS that does not support OpenSSL. It is in fact pre-installed in almost every Unix and Linux distribution by default. Being open sourced, anyone is allowed to download the source code for OpenSSL and build binaries for it. OpenSSL has an excellent support for various SSL and TLS implementation. That's one reason why most web servers these days use OpenSSL for securing their communication. You can use it to generate keys and certificates to set up TLS or HTTPS for your web server. OpenSSL also provides API that can be used by a developer to write their own security software. The core library of OpenSSL itself is written in C language. You can use the functions provided in that API to write your own security solution. OpenSSL is widely used on the internet to secure websites using HTTPS. Popular web servers such as Apache, Nginx, and Tomcat has built-in support for OpenSSL. It is important to understand how versioning works for OpenSSL. At present, there are two versioning schemes for OpenSSL. There's an old versioning scheme, which is used by OpenSSL version 1.1.1, and there's a new versioning scheme used by OpenSSL version 3.0. In the old versioning scheme, there are 3 digits separated by a dot and followed by a letter. The first 2 digits shows the major release version. It is not backwards compatible with application that uses an older version of OpenSSL. The final digit indicates that some new features or improvements were added to OpenSSL library. It is backwards compatible, and upgrading your OpenSSL library to a newer minor release should not affect your existing application. And then there's a letter at the end which is only used to indicate that some bugs were fixed or some security issues were addressed. Starting with OpenSSL 3.0, a new version scheme has been introduced. This scheme is divided into 3 parts: major, minor, and patch. Just like the previous versioning scheme, a change in the major release is not backwards compatible. Minor release number indicates that some new features were added and it is backwards compatible. The letter used in the previous versioning scheme has now been replaced by a digit for patch version. So instead of changing the letter, you would see an increment in the patch digit. There are 2 important libraries in OpenSSL: LIBSSL and LIBCRYPTO. LibSSL is used by OpenSSL to perform SSL TLS related operations. LibSSL is dependent on libcrypto. libcrypto is used by OpenSSL to perform cryptographic operations such as encryption, signing, hashing, and key agreement. I think it is important to understand what OpenSSL engines are. OpenSSL engines provide a software or a hardware implementation for a cryptographic function. For example, there are some hardware-based devices which provides fast and secure cryptographic operation. These devices can be used with OpenSSL with the help of an engine. To give you an example, I would use an example of a property dealer. I'm sure most of us are perfectly capable of selling a property on our own. However, if you ask a property dealer, they should be able to help you sell your property much faster. They have contacts, they have information about the market, and some of them are good negotiators. Similarly, OpenSSL can perform all types of crypto operations, but it's a software and it has its own limitations. There is a risk of your keys getting compromised. Your computer could be old, so it may not be fast enough for bulk operations. To safeguard your keys and to accelerate your bulk operation, you could use a hardware-based device such as a hardware security module. Engines are libraries that would allow OpenSSL to talk to that hardware. I will be dedicating a video on engines very soon where I will talk about OpenSSL engines in greater detail. Now I will show you how to install OpenSSL on Windows and Linux. Earlier in this video, I said OpenSSL is installed by default on Unix or Linux operating system. I am logged into my Linux virtual machine and I just executed OpenSSL version command. I am seeing an output, so it says OpenSSL 1.1.1f, and I also see a date. I'm guessing this is the release date. So this OpenSSL release was pre-installed on this machine. Now, what if I want to get something new? So for example, if I execute sudo apt get install -- only upgrade OpenSSL, going to enter my password. It says OpenSSL is already the newest version. Well, I know for the fact this is not true, because if I go on to the OpenSSL website, so this is a site for OpenSSL, openssl.org. If I click on the download section, I can clearly see that OpenSSL 1.1.1 Q is the latest release that I have. One of the main reasons why an upgrade is not available is because there are many programs and services in Linux that are dependent on OpenSSL. Upgrading OpenSSL to a newer version may break some of those programs. For that reason, most Linux distribution would just stick to the OpenSSL version, which is known to be stable. But what if I just want to test a new version of OpenSSL? Well, if you want to do that, then you would have to download this source file, and I'm going to do exactly that. So I'm going to right click on this, copy this link address, and on this machine, hold on, let me clear the screen. We'll create a new directory called OpenSSL and wget. Oh, sorry, one second. Copy link. Okay, wget. And I have downloaded the source file. So now I will show you how to build OpenSSL from source. I'm going to clear the screen. I already have the source code, so I'll do tar xf OpenSSL. So here's the directory which contains the source code. So this is a source code for OpenSSL. If you want, you could just, I don't know, make changes to it, build something new out of it. It's up to you. I'm going to use it as it is. So the first thing you want to do is configure the make file. So for that, I'll do config and I'll hit enter. So config is a script that is inside OpenSSL, like this directory. So when I execute the script, it will automatically detect what version of Linux I'm using, and it will also check whether I have the necessary dependencies. If all of it is good, then it will create a make file. Once the make file is created, we can proceed with our installation. So I'll clear the screen. Next, what I'm going to do is I'll execute make and I'll hit enter. Now this is the build process. It is actually using all the C files that exist inside the OpenSSL directory, and it is building binary for it. Make command has completed, and I think it took around 2 to 3 minutes to complete on my machine. Now, depending on how powerful your computer is, time required to build may vary. So if you have a high-end powerful computer, it may take less time, and if you have an older computer, then it may take longer. There's another way to make use of make command. Now, when I execute make command, it keeps compiling a single source code one at a time. There's a way to speed things up. So I'll clear the screen and ls CPU. So this is a CPU that I'm using. Currently this virtual machine has 8 CPUs assigned to it. So there are like 8 cores on this machine. Now I can use these extra cores to build OpenSSL faster. And to do that, I will use the command make-j. So I'll clear the screen and I will also execute make clean just to remove all the binaries that were built earlier. And I'm going to time it this time. So I'll do time make-j. So I'm using time command just to check how much time it takes to build using make-j. I didn't do this earlier. I'm doing it now. So I'll hit enter. Now make-j will try to compile multiple source files depending on how many CPU cores you have. So right now make-j is executing multiple compile commands simultaneously, which will result in faster build process. It's still going. I hope it's not going to take 2 to 3 minutes. I'm pretty sure it took like 3 minutes, around 3 minutes. Okay, I'm guessing it's almost there. Okay, there it is. 36 seconds. So the entire build process just took 30 seconds. So without make-j, it took me like 2 to 3 minutes. I think it was around 3 minutes, but with make-j, it took just 36 seconds. All right, I'll clear the screen. Once make has completed, the next step is to install the build binaries. So for that, I'll execute the command make install. I'll hit enter. It's asking for my password. Oh God. Okay, it's installing all the binaries and the man files and the header files and other things. This shouldn't take long. It should take like maybe 20 to 30 seconds. All right, make install has completed, and I think it took about 40 seconds. So I'll clear the screen. Now, if I execute OpenSSL version, I still see OpenSSL 1.1.1f, but the source code that I compiled was OpenSSL 1.1.1q. The reason why I'm still seeing an old version of OpenSSL is because the old version of OpenSSL still exists in user bin OpenSSL directory. So if I do user bin OpenSSL, hold on, and version, and I see 1.1.1f. However, the make install command that I executed, it installed OpenSSL in user local bin directory, OpenSSL. And I get an error. So there is a binary and it gives an error. Well, I am getting this error because this binary is expecting to see shared library for OpenSSL 1.1.1q, and it can't find it. Instead, it's getting library for some old version of OpenSSL. So if I execute the command ldd user local bin OpenSSL. Okay, so libssl.so, this is the location of that file, and libcrypto.so, this is the location of that file. I know for sure that this is not the shared library that was installed using make install command. It exists in user local lib directory. So these are the files that this binary is expecting to use. There's a way to fix this, and let me show you how to fix this. I'll clear the screen. I will use ldconfig, which I think is more appropriate. There are other options such as manually copying the files into user lib directory, and I don't like it. Another way is to simply set ld library path environment variable, which I don't want to do. I like ldconfig because it maintains an index of all shared libraries required by an executable file. So all I need to do is update it with the location where the new library of our OpenSSL exists. So this is the new library, and I just need to update user local lib in ldconfig. So to do that, I will first need to create a conf file, and so I'll do sudo -nano etc ld.so conf.d, and I'll just call it ossl.conf. Okay, here's the password. So my new libraries are in user local lib. I'll save the changes, and all I need to do is ldconfig, hit enter. Oops, sorry, permission denied, sudo. And now if I do user local bin OpenSSL and version, I can see OpenSSL 1.1.1q. Actually, I don't even need to mention the entire path. I can just do OpenSSL version, and that should be fine. And this is how OpenSSL is built in Linux. Windows operating system does not have OpenSSL pre-installed like Linux. You need to download it and install it yourself. However, if you go to openssl.org, you would find that they don't provide any installer. It does not matter if you're using Windows or Mac or Linux. You only see the source. There is no installer from this website. So if you want to download an installer for Windows, which is actually the easiest way to install OpenSSL on Windows, you could head over to this website, slproweb.com. On this website, you should see MSI or exe type installer for OpenSSL. You can just download whatever you need from here. So there's a 64-bit, so Win64, this is a 64 build of OpenSSL. Win32 is the 32-bit. There's also a light installer, which is of 5 MB in size, and there's a normal installer, which is of 140 MB in size. I mean, this is for 3.5. There's a different size for 1.1.1q. I'm sure this should be easy for you. However, if you don't trust installers provided by a third-party website, then you could build OpenSSL from source on Windows, just like we did on Linux. You can simply download the source tarball from openssl.org and build your own OpenSSL binary. However, building OpenSSL on Windows is not as easy as it was on Linux. This is because there are some prerequisites that you need to install. So first of all, you need Visual Studio with C compiler, which will be used to compile the source code. You also need Strawberry Perl, which is required to execute some scripts. And you need NASM, also known as NetWide Assembler. This will be used to generate those binaries. Let me show you from where to get those programs. So the first program that we need is Strawberry Perl. And this is a website, strawberryperl.com. And depending on what you want, you could download the 64-bit installer or the 32-bit. The other thing that we need is NASM. So this is a site and the stable installer, and you need Visual Studio, and you should be able to download it from here. I already have these programs downloaded on my machine, so I'll just show you how to build OpenSSL on Windows. Alright, so I have I have Visual Studio installed, I have Strawberry Perl installed, I have NetWide Assembler installed. Now, before you begin compiling the source or building the source for OpenSSL, here's something you need to remember. On Windows, you would have to use Visual Studio Developer Command Prompt. So you can't just open a normal command prompt and start your building. You have to use your Visual Studio Developer Command Prompt. I am using x64 native tool command prompts for Visual Studio. I mean, I've always been using this command prompt and it has always worked for me. So that's the reason why I'm using this. My command prompt is also administrator. It's also, I mean, you see administrator over here. So it means my command prompt is already elevated. And on this command prompt, on this computer, I already have the OpenSSL tarball downloaded. I've already extracted the tarball. So if I go into this directory, I have my source code, for OpenSSL, source code, script, readme files, whatever. I mean, everything is in here. Okay. So the first thing I'm going to do is, let me clear the screen. I'll run the command perl configure vc, or wait a minute. Let me just run perl configure. So when you execute perl configure, you are going to see the list of different architectures that are supported by this script. As you can see, there are like so many of them. The one that I'm going to use is VC Win64A. I'll select this. Okay, clear the screen again. And now I will execute the command perl configure. And I'll paste what I copied, -- OpenSSL dir. This is the directory where I want my OpenSSL to exist, Win64A. And prefix is the location where I want OpenSSL to be installed. There are two different things, OpenSSL dir and prefix. They both mean two different things. I'll tell you in a minute. Let me compile this command. So what was I going to do? Oh, Win64A, and hit enter. So OpenSSL dir is the location where OpenSSL is going to store all the configuration files. So later on in this tutorial, I will be mentioning a file called openssl.cnf. I will also talk about private directory, certs directory. So OpenSSL dir is simply the location where all those files exist. Prefix is actually the location where OpenSSL binaries will be installed. The binaries, the docs, the header files, that's what prefix is. I think when I was executing this command, I said that OpenSSL dir is the location where OpenSSL is installed. Well, it's just the location where the configuration file and other required file for OpenSSL exist. It's not the same as prefix. Anyway, so this command has completed, and it has generated a make file. As you can see here, it has generated a make file. So I'm going to run the command and make, and I'll hit enter. Now this is a long procedure. I think it takes on Windows it takes longer than Linux. So on this machine, on Linux, I think last time it took around 2 to 3 minutes, around 3 minutes. So I'm expecting this build process to complete in like 3 to 4 minutes. So anyways, I'm gonna pause this recording, and I'll be back when the build has completed. Okay, build process has completed. Now you need to run the command and make install. And when I hit enter, it should install all binaries. And the binaries are installed. I'm going to exit out of this. I already have the OpenSSL directory where I installed all the binaries set in Windows path. So if I execute the command path, I should see, where is it? Okay, so this is a place where the executable of the binary that I just installed exists. And if I run the command OpenSSL version -a, OpenSSL 1.1.1q, and some other information. And that's how you build OpenSSL on Windows. That's all I have on OpenSSL in this video. Please leave a like if you found this video to be useful. In the next video, I will show you how to use OpenSSL. Don't forget to subscribe if you're new here. If you have any questions, then please use the comment section below, and I'll try to answer them as soon as I can. I will be uploading my notes to my GitHub page for you. Head over there if you need them. Link is in the description below. And like always, thank you so much for watching. I will see you soon in my next video. See ya.